All right, today you're going to be learning how to graph the sine and cosine graph. We're going to start with the sine, and we'll start with the parent function. Just like you've done in the past, you've graphed the parent function, and then you learn how to transform it using the a, b, c, and d. Those values are going to be the same ones we use for our trig functions. The a is still the vertical stretching and compressing. B is horizontal stretching and compressing. C is the left and right movement, and D is the up and down. And we'll talk a little bit more about that in a second, but let's start with the parent function. You should be really good at your unit circle now, so you should be able to fill out a table of values very quickly. With the sine of x, we know on the unit circle, sine is the y value. So if we were looking for our sine for 0, well, on the y, that is 0. For pi over 2, my y value is 1. For pi, my y value is 0. 3 pi over 2, it is -1. And at 2 pi, it's back to 0. That right there is considered the full cycle of the sine curve. So it's going all the way around the unit circle. From 0 to 2 pi makes it all the way around. I picked these points on purpose because they're whole numbers that make it easier for you to graph. You could still use any of the other ones. For example, if we did pi over 4, you should know that is the square root of 2 over 2, which is approximately 0.7. Just not as easy to get it on the graph, but it will be as part of your graph. Now, as we work backwards, remember negative pi over 2 is coterminal with 3 pi over 2. So this would be -1. And then at negative pi, our y value would be 0 because that is coterminal with pi. So we're going to start graphing, and I'm going to start at the 0, 0 so I can show you that one full cycle. So here is 0, 0, pi over 2, and I'm going to make this 1 right here. So these tick marks will go by half. So I'm going to label that as 1, and this is -1. It's going to make it a little bit easier for you to see the graph. At pi, it is 0. 3 pi over 2 is -1. And at 2 pi, it is 0. So this is one full cycle of the sine curve. Kind of looks like this wave thing. At this point, it repeats because then we're just going around that unit circle more times. So we're going to have those coterminal angles. When we went to the negative side, negative pi over 2 was -1. Negative pi was 0. This would be a +1 and 0. So we get another cycle of that unit circle. One full cycle is called the period of the graph. That distance is 2 pi. In the distance of 2 pi, we got one full cycle of that sine curve. And then again, it repeats. So this is my parent function for the sine. Some important values is right here at 0, 0. 2 pi is the full cycle, so it has to be back at that 0 mark after 2 pi. The sine curve in the middle is also in the center, and then it goes up on the left here and down on the right. So this is the parent function, goes this direction right here. So 2 pi is the period. That's one full cycle. The domain is from -infinity to infinity. It goes all the way to the left, all the way to the right, because this would keep going here. Our range is from -1 to 1. So the biggest sine value that we have is +1. The smallest is -1. So my y values are all between -1 and 1. It keeps bouncing between those two. The amplitude is the distance from the center to the top or the bottom of the graph. And so that distance is 1. It's from the center to the top or the center to the bottom. So it's a distance of 1. There is our sine parent function. That's all the stuff that you need to know so that you can transform this graph. So make sure that you know all of the different parts of that sine curve. Now let's talk about this cosine curve. Again, we're going to start with the parent function. And so if we think about the cosine values, those are the x values on the unit circle. So at 0, my x value is 1. That's at 0.10. Pi over 2, it is 0. At pi, it is -1. 3 pi over 2, it is 0. And at 2 pi, it is 1 again. So again, this is one full cycle since we returned to that initial point where we're at. So 0, 1, my cosine graph starts right here. At pi over 2, it's 0. At pi, it is -1, 0, and then 1. This is one full cycle of the cosine curve. There it is. From here to here, we've got one full cycle. It goes 2 pi is that period. And then it starts to repeat after that point. So this does end up looking somewhat like the sine curve. And then it just looks like it was moved to the side. So it looks like we took the sine curve and moved it a little bit to the left. So instead of being up here, it went over here. You can get the sine curve to fall on top of the cosine curve using transformations. So it's got a lot of similarities. This is 2 pi, this is 1. It goes from -infinity to infinity, and then our range is from -1 to 1. And so you need to get really familiar with this cosine curve. We did forget to put this here. At -pi over 2 was 0, and here it was -1. You need to get really familiar with this cosine curve so we can use transformations to graph it. All right, so let's look at some of those transformations now and what that transformation equation looks like. So A times sine B x minus c plus d. Again, this A, B, C, and D are the transformations you dealt with all in Algebra 2, and we looked at the beginning of the school year. Now, in this case, a vertical stretch, affects the amplitude, it tells us here. So let's look at that graph and see why that happens. Here is my sine graph. A vertical stretch is when I take the graph and I pull up and down like this. This would be a vertical stretch. A vertical compression, I would take it and push it in. So this is a vertical compression. That means that instead of going here, if I compressed, it would go down. If I stretched, it would go up. Same thing with this point. It would stretch down or compress here. It is not going to change the period of the graph. Those values are still at 0, and 0 times anything is still 0. It would just go higher and then lower at our peak here. That's what the amplitude difference is, and that comes from this A value. So A affects the amplitude. Right here, it shows us that B is going to affect the period. So let's look at that. A horizontal stretch would be if I took the graph here and pulled this way. Now we're going horizontally, or we're compressing horizontally this way. That's going to affect this period. So instead of having one full cycle of the sine curve here, if I compressed it, then it would happen in a shorter amount of time, distance here. If I pulled it, then it would happen in a longer distance. So to figure out that distance, we take 2 pi, which is the parent function period, and divide it by the B value. That's going to give me the period. Once I have that, then I'm going to get a full cycle within that amount of distance. C is our horizontal shift, and D is our up and down, just like the rest of them. All right, so let's look at some of the graphs. On a test, you can have a chart like this where you have to come up with all the different values, and you should be able to do that just by looking at the equation. Here we have a 4 in the place of A. That's my amplitude. We said a vertical stretch affects the amplitude. So it's going to go 4 up from the center and 4 down from the center. The B value affects my period. So I'm going to do 2 pi over 2. This reduces, and so we get pi. There is no phase shift, no vertical shift. My domain is all real numbers, -infinity to infinity. And for the range, it is going to go 4 up from the center and 4 down, we said. So the smallest point is going to be at -4. The biggest is going to be at +4. I'll do one more with you guys, and then you guys should try one. So right here, our amplitude has no vertical stretch or compression, so it is going to be 1, just like the parent function. There's no horizontal stretch or compression, so the period is going to be just like the parent function, 2 pi. And then it went to the right, 2 pi over 3. Remember, when it's minus that C value, that's what it's going to go to the right. And this right here is going to go down 4. All right, that does not change our domain. it does change our range. Our center is going to go down 4. So my new center is going to be at -4. The amplitude, 1, so it's going to go up from -4, 1, and down from -4, 1. So the lowest point is going to be at -5, and the highest is going to be at -3. Now go ahead and pause the video and go ahead and type this in, or work that one problem. You try it, and then come back and see if you got it correct. All right, so here is the values. Check to make sure that you got those correct. On the period, we took 2 pi and we divided by 1/2, and so you keep change, flip. And so when we flip this 1/2 and multiply it times that, we get 4 pi. All right, so now let's practice graphing these things, and we'll start really easy here with 3 sine of x. In this case, the only thing that we have is an a. The a value is the vertical stretch, so it affects my amplitude. So my amplitude is going to be 3. Since there's no b value, it is going to still have a period of 2 pi, just like the parent function. So my center is still going to be right here at 0. My amplitude is 3, so I'm going to go up 3 from this, and I'm going to go ahead and graph a little dashed line at 3, and then another one at -3. The reason why I do that is because now it gives me the minimum value and the maximum value that I'm going to have. And so I don't have to count every single time. I know my maxes are all going to go up here. My mins are going to go right there. Our sine curve starts at 0, 0. So this is my first one. The period is 2 pi. So I know it's going to be in exactly the same point when I have a distance of 2 pi. For the sine curve, it goes like this. So here and here, it is at the center, and then right in the middle, it's at the center as well. So for the middle value, I know it's going to be at the center. And then it goes up in between these two. So right in the middle, I'll go up and down. Same thing here. And then I connect my dots. And so there is my sine curve with this vertical stretch of 3. My domain has not changed, but my range is going to go from -3 to 3 because that's my smallest y value to my biggest y value. All right, let's try one that's a little bit harder now. All right, for this one here, we've got y equals sine of 1/2 x plus 2. So we've got an up 2 because of this right here, and we have a horizontal stretch by 2. That is going to change the period. So we take 2 pi and we divide it by 1/2. I keep change flip, and so that is going to be 4 pi. That means I'm going to get one full cycle within 4 pi. That is not a lot. That means I'm only going to have one full cycle in this entire graph because this is -2 pi to 2 pi. So this is going to be 4 pi. I'm only going to have one cycle within that entire thing. My amplitude did not change. And so here we go. This went up 2. So I'm going to change my center to up 2. We're going to go up 1 for the amplitude and down 1 for the amplitude. My sine curve starts at the center. So I'm going to have a point right there. It has been stretched by 2 pi. So the next center point is going to be right here because our final one would be at 4 pi and it's way over here. In the middle of that, it goes up. So this is the only part I have within that 2 pi. And so right here, and then back at the center. And so there's one full cycle. This is technically the first part of the cycle, and it would just go this way. But this is the only other part I could put on the graph because it goes to the negative side. It would keep going, not at a very fast pace there or there, so it's not going to hit another point between those. Our domain is negative infinity to infinity, and our range is from 1 to 3. All right, now it's time to try one that's a lot harder. So this one's got a lot of transformations. It's got the negative, which is the reflection across the x, a vertical stretch by 3, a horizontal compression by 1/2, a left pi over 2, and down 3. So we've got a lot of different ones going on there. Left pi over 2, down -3. And we have a reflect across x. Now, the period has changed to 3, so I want to make sure that I take that into account. And our period has changed because we've got this 2 here. So I would take, whoops, I wrote that in the place of the amplitude. The amplitude was 3. This would be 2 pi over 2. The 2's cancel and we get pi. So every pi, we're going to have a full cycle of this sine curve. So first thing I'm going to draw is that -3 is going to be my new center. So I'm going to draw that center in. My amplitude is 3, so I'm going to have a top right here at 0 at the x-axis. And then my bottom one is going to be right here at -6. And so I know all of the values are going to fall between that. So I can go ahead and write my range to be from -6 to 0, because I know this entire sine curve has to fall in between there. All right, our sine curve starts at the center, so it would be right here. But we need to move it to the left pi over 2. So I would go right here. The period is pi. So pi from here would be right here. This is where it needs to end. So I need one full cycle of the sine curve to happen right there, from here to here, because that is 1 pi. Now I know my sine curve looks like this. So beginning point, ending point, that's what I have here. This middle point, again, is at the center, so I'm going to have that right there. I would normally go this way, but there is a reflection across the x-axis. So the point that would be up here is going to reflect and come to the bottom, and the point that was at the bottom is going to reflect and come to the top. Now, I'll be honest, on the test, we're going to stick to 2 or 3 transformations. This one right here has 5, so that's a lot. But I want to make sure if you can do this, you can do the ones on the test. So here we've got 6 units, and there's a new one. So every 6 units, I should have a new cycle of this curve. And in the middle, it should be back here. And then in the middle of those, it goes down and up. So there is another cycle. 3 and 3. Middle on the bottom, middle on the top. We would do the same thing on this side. And there's our full graph. Again, the range is, the domain is from -infinity to infinity because it goes all the way from the left to the right. So there's your sine curve. All right, let's try a cosine curve just so you can see that. We'll skip to this one right here. Cosine does work exactly the same, except we're starting with the cosine curve instead of the sine curve. Again, we're looking at 1, 2, 3, 4, and 5. Since this is the cosine one, I'm going to go ahead and scratch out this negative. So we're going to pretend that's not there so that it's a better example for you. So here we go. We go left, pi over 2, and down 4. We have an amplitude of 3. And then the period here is going to be 2 pi divided by 2. That's our parent function divided by our b value. All right, this went down 4, so 1, 2, 3, 4. And we're going to start with our center right here. Its amplitude is 3. So here's going to be my top values. Here's going to be my bottom values. All right, for the cosine curve. The cosine curve starts at the top. So this is where I should start. It went to the left pi over 2, so it's going to go right here. And so my curve would be right there. Since the period is pi, I'm going to go a distance of pi, and it needs to be back in that same place. And so that cosine curve, if you remember the parent function, starts at the top, goes down, and then back up. So it looks like this. We're at the top and the top. That's what I've got right there. So right in the middle of that is going to be the bottom. And then in the center of that would be where it hits our center mark here. So there is one full cycle of that cosine curve. Now we would follow this pattern. And so in between here, that's 6. So I know that every 6, I'm going to be back at that top. And in between those, I'm going to be way at the bottom. And then in between those, I will be in the center. We see more cycles here just because the period is smaller. Every 6, I'm back at the top. In the middle of those, I'm at the bottom. And so there is our cosine curve. You start with that parent function, and then you start to move it around with the transformations. It does make it easier by doing the center, the bottom, and the top graphs. It helps you just go through there. I didn't have to count how many up, how many down each time, since I knew it's going to be at that top and the bottom. And this is going from -7 up to -1. So there's your cosine curve. If you know that sine parent function and you know that cosine parent function, then you should be able to graph any other one with the transformations. Make sure you practice these. You should know how to graph both of them now.